Hey everyone, welcome to today's lesson, and today's lesson is lesson 1-1, and in this lesson what we are going to be doing is evaluating and simplifying a given function. Our language objective is to explain how to evaluate a function. So let's take a look at our do now. Okay, so let's take a look at our do now for today. Today we are answering the following. So I want you guys to pause the video. Let's see if you remember how to get an output value given an input value. So pause it and we'll get back together. Okay, so this is what you should have got. For number 1, your input is -1. I highlighted it. That means that anywhere I see an X, I'm going to replace it, substitute, and I get an output value of 0. For number 2, the same thing. We have an H function, H of 3 we're looking for. So the input is 3. Wherever you see the X, you're going to replace it with 3, giving you an output value of 27. So this is taking us back to input-output, evaluating functions. So how do we evaluate functions? Before we evaluate a function, we need to know what each piece of the function represents and means. So we have this F piece. The F, it's not always an F, most often an F, is the function's name. So you could have an H function, you could have an A function, you could have any function whatsoever. Then we have this piece here, which is our X. Our X is our input. So we have an input value. Then we have the entire f of x. This entire f of x is telling us our output value. And lastly, we most often have something here. X plus 3, x squared minus 2x plus 7. All of those are the rule, so the function's rule. So what are we going to do? That function rule tells us a lot and helps us with the output value when I'm given an input value. So let's take a look at our first example and let's see how we go through it. So here we have example 1, and we're asked to evaluate and simplify the following functions. So they gave us an input of f of n. So we're going to stay away or get away from the numerical inputs, and we're going to actually have some algebraic inputs now. So in this case, we're finding f of n, and they gave me the entire f of x piece. So what we are trying to do is think of this f of n as your input. That n is the input. You are going to be replacing wherever you see an x, you're going to replace it with an n. So I'm going to rewrite. So in this case, I'm looking for f of n. My rule is 2 times x, but no longer do I want an x. I'm going to replace it with our input of n plus 5. So this is a nice easy one because that's all I have. My input is now an n. My original input was an x, but I don't want an x anymore. I want an n. So let's look at the next one. The next one we have find f of n squared minus 1. So same kind of thing. This is our input that we want. What they gave us originally is f of n is equal to -2n minus 4. What we are going to do is, instead of using the original n functions rule, what we are going to be inputting is the new input. So let's rewrite f of n squared minus 1. That's my new input. I'm inputting that into the original n. So in this case, I have -2 times n squared minus 1. That's my new input minus 4. I'm doing exactly the same thing that we did in the do now, only that now we have some algebra piece that we're inputting. All right, so let me keep going because I do need to clean this up. This would be a -2n squared plus 2. Drop down. So my function would be -2n squared minus 2. For number 3, we are asked to find f of w plus 2. They gave me f of x is equal to 2x squared plus 4. So what are we doing? This w plus 2 is our new input. We no longer want this x, so I'm going to be replacing the original x, which in simple terms means look at all these x's and change them to the new input. I'm going to rewrite. I'm going to substitute my new input into the x. And at this point, it's just a matter of evaluating, distributing, and so forth. So I'm going to start with this distribution here, then distribute the 2. Make sure you follow order of operations, right? Exponents first. I am going to distribute the 2 and then start doing my combining like terms. And what we end up getting is f of w plus 2, 2w squared plus 8w plus 12. All right, so it says evaluate h. H is our function. Our input is 2a minus 1. Our original function was this h of x. But again, we don't want an x anymore. We want our new input. What I'm going to do is replace all the x's. All right, at this point, it's all about my algebra skills. So I need to do distribution. I need to combine like terms. So I'm going to quickly do that and get to my final answer. After I did foiling, after I did all of my math work, this is what I end up with. So really quickly running through the steps. First thing you should be doing is the foiling piece, right? I showed it here. You can do multiple steps in one shot. So I also did this piece right here. I distributed that -1, giving me that. So I started doing my foiling. I got 4a squared minus 4a plus 1. I distributed the 2. I even combined the +1 and +3 to give me a +4 right away. So I didn't have to keep dropping that down. It gave me my final answer of, again, 8a squared minus 10a plus 6. Last one, evaluate p of 2x minus 4y. And they gave me, again, my original p function with its rule. So what we are doing is we're taking our new input and replacing the old input. So I have p of 2x minus 4y. It's the new input, and I'm going to replace all of my original inputs, which were a. Okay, so I substituted. At this point, I'm going to do my foiling. And at the same time, I'm going to knock out the distribution as well. So I'm going to try to do double work in one shot so I don't have to write too much. Okay, so I have here, I expanded it, I did my distribution. I'm going to just keep going. So I actually expanded it just a little bit more. I'm going to combine like terms and distribute that 2. After doing my distribution of that 2, I end up with this long polynomial, but I am going to keep it. There wasn't any like terms I could combine and make it smaller. So when we input the 2x minus 4y, this is our new output. When you have these questions, be very, very careful with your algebra. You want to work slow and keep learning, keep growing. I will see you in our next video.